Alright, problem number 6. Evaluate each definite integral, either using a geometric area or the fundamental theorem of calculus. So for this first problem, since we don't know how to integrate something like that, a composition of functions, if you may, square root of x and 16 minus x squared, let's go ahead and evaluate it using a geometric area, because if you remember from Unit 1, the square root of 16 minus x squared is actually the graph of a circle, or a semicircle, really. So 16, square root of 16 is 4, so that tells you that's your radius. So basically we've got a circle that's up 1, 2, 3, 4, 1, 2, 3, 4, goes like that. Boop. It's going to continue over there too, but we're only looking between 0 and 4. So if you integrate that, the area is just going to be the area of a circle, which is pi r squared. Our radius is 4 squared, but if you look, it's really just a quarter of a circle, so we should divide everything by 4, which we're going to get some simplification there, and our area is going to be 4 pi. Cool. Part B, integral from 0 to 2 of 3x squared plus 4. Let's integrate that using fundamental theorem of calculus. So if you integrate that, you're going to get the integral of 3x squared. Can you hear my dog whining? She's crying to come in. Integral of 3x squared is going to be x cubed. The integral of 4x, the integral of 4x, we're going to get our x squared divided by 2. So 4 divided by 2 is 2. So we're going to get x cubed plus 2x. Let's evaluate that from 2 to 0, which is nice because all we have to do is substitute 2 in. So we get 2 cubed plus 2 times 2 squared. Well, 2 squared is 4 times 2 is 8. 2 cubed is also 8. So we're going to get 16 for part B. So moving on to part C. This one's a little bit trickier than the other ones, and let's go A, B. Part C, absolute value function. You can do this either way. I'm going to do this by sketching myself a little graph. So if we think about the function x minus 3, absolute value of x minus 3, that's the same as the absolute value of x, except that minus 3 shifts it to the right. 1, 2, 3. So this is so crooked, but that's okay. So my vertex is going to be right there. Other than that, to the right, it's like a linear equation, y equals x. So it's going to go up 1, whoop, like that. To the left, again, it's a mirror image. So it's like negative x there. So it's going to go up 1, up 1, up 1, up 1. And we're going to get, so that was 1, 2, 3, and we were up 1 more. 4 right there. So all I need to do is find the area of those two triangles. Well, that distance right there is 2. That distance is 2. Sorry, that whole distance right there is 1, 2, 3, 4. And that distance right there is 1, 2, 3, 4. So really, we just got two triangles. The area of a triangle is base times height divided by 2. So that first triangle, we're going to have 4 times 4 over 2, plus this triangle here, which is going to be 2 times 2 over 2. Simplify that. 4 divided by 2 is 2. 2 times 4 is 8. 8 plus 2 over 2 is nothing, so 2. So 8 plus 2 is 10. And that's our answer for C. Part D, finally, last one. Again, integrate this using the fundamental theorem of calculus. So if you integrate 2x, you're going to get x squared. Integrate 3, you're going to get 3x. And we're evaluating that from 5 to 0. So substitute 5 in, you get 5 squared plus 3 times 5, which is just 25 plus 15, which is 40. And we're done. Yippity yay.